Okay. Uh, can you see my screen?
Yes.
Yes, we can see your screen.
Fantastic, but there is something wrong with the camera, but we can go with this way, I think. Well, the camera is functioning, my camera, but I do not know why it is not showing it.
Okay, I believe.
Start my video. Okay, I got it. Fantastic. So I'm here, alive and kicking. Okay, so my presentation will be much simpler than most of the presentations so far. And in fact, it will concern basic concepts and tools from algorithmic information dynamics, but it will mostly focus on data engineering aspects. Here we have the main components, concepts and tools, and finally we will discuss some preliminary results of a pilot study. Speaking about what contribution can have this research, it would be a step forward in using time-dependent BDM, a procedure for calculating this type of BDM, an example of using time-dependent BDM as features for building a traditional ML model, and finally an attempt at using these concepts and tools for a clinical purpose. Here we have two basic concepts, algorithmic complexity, or Kolmogorov-Chaitin and respective formula, and the block decomposition method that was nicely explained by a few people before this. Speaking about data, they come from Kaggle competition. The format is intracranial EEG recordings in 10 minutes clip as MAT files representing signals from 15 to 24 electrodes from 4 dogs and 2 humans, segregated as interictal and preictal, and the task was to find the best solution of classifying this clip. In this particular research, I was using data of the dog number 2. After converting this data to CSV and arranging it this way, channels as columns and observations as rows, we will get up to 240,000 observations per clip. And here we have the electrodes, here we have the time axis, and for calculating BDM, we will need to split these matrices in in fact, is a matrix, a big matrix in small matrices. In this case, probably the best solution will be 16 by 16 to be able to use 4 by 4 BDM for calculating algorithmic complexity without overlapping. So doing this, we will get this data as 16 by 16 matrices. Then we can apply algorithmic complexity calculator with the respective function BDM 4 by 4. Of course, using online version is quite difficult because we have a lot of such matrices per every clip, up to 15,000 such matrices. So because of this, the core of the R version of this calculator was extracted and integrated into data processing pipeline. Finally, we can calculate the BDM and can plot it as a time series. And we can see here the first 7 steps with BDM. Next, if we try to apply this to real clips from this competition, on the screen we have on the left side an interictal or normal clip, and on the right side problematic or a preictal clip. So just simple visual analysis will not provide us with too much information. We can try to aggregate along the time axis. It's a little bit clearer, but probably not enough. If we apply simple exploratory data analysis like density distribution and calculating mean BDM and plotting this distribution, we can see that we have an evident shift of the BDM coming from a preictal group. But if we analyze separate segments, we can be confused because we can get a completely opposite shift. So you can see this on the screen. I hope my camera does not overlap. And then we can use text analysis tool. In fact, I was using different approaches, and this proved to be one of the best. And what we have here, we have BDM value as time series. We can convert this applying a simple function like number to letters to text, and finally we'll get a clip as a text where words are BDM values rounded and converted to letters. And finally we can calculate different statistics using this type of tools, and here we can see the term frequency for two separate groups, interictal and preictal. The whole process looks like on the screen. By A is denoted the original or numeric version of BDM time series. B is letter version, and in the middle there is a kind of mapping. C represents the vocabulary or the words or BDM value, unique BDM values present in this clip. D is the dictionary or the an hypothetical total amount of words we can get by permutation. 10 symbols by 3, we will get 1,000 such possible words. And finally, the resulting array will be such an array that can will include this 1,000 with 0 for missing words. Next of importance is so-called latent directly allocation, that in fact is one of the common tools for this field. We have the scheme here. What is important is K or topics present here, and beta as a parameter of distribution. Looking at some notations here, number of topics K, we have 2 topics, number of words, unique BDM values, and number of documents, in our case, separate clips, a collection of these clips, 774 such clips, and a number of other parameters of importance is B. And for applying this, we can use so-called collapsed Gibbs sampling, and we have the notation for this that can help us to calculate and extract different probabilities concerning words, topics, collection, etc. And finally, the clip will look like on the screen. For every clip, we will have such a matrix where we have a column with words, unique BDM values, and a beta log ratio, and the words that will be missing will be denoted with 0. Here is how the distribution of such words will look like in case of 30 top words in a topic, 1 or 2, preictal or interictal. And the final format of the data that will be fed to the algorithm, machine learning, will look like on the screen. The first column category is labeling of the cases, 0 for preictal, interictal, and 1 for preictal, and the rows are samples, and V1 to V1000 represent the beta log ratio for these samples. And skipping some details, I would mention that I stopped at a multi-layer perceptron, or 4 layers, 2 hidden layers with 200 units each, a rectifier with dropout activation function, and soft marks for the output. And on the third column, we have the performance metrics, and diagnostic accuracy, you can see, is 0.94. For illustrating all the steps, I prepared a Shiny application that is available on the address just below the title of the slide. All the steps can be performed, including calculating and plotting BDM. So in fact, and finally, a clip can be classified like on the screen. In this case is an interictal clip. Limitations. In fact, there are many limitations. Main one are all the limitation of a pilot study. When we have only one subject, limited volume of data that are important for an effective machine learning model. And the final limitation is a kind of warning. And in fact, the previous presenters, they provided a kind of solution to this, and it consists on the fact that most of the machine learning model are based on statistical principles, and because of this they can vanish or even skip much richer metrics that comes from algorithmic complexity. So, and this issue is quite interesting and probably deserves a much longer presentation. I will refer only to one paper where it is described, but there are a number of such papers. So, in fact, this is all I was to say, and I'm not sure we have time for questions and answers, but there is chat. It can be done over there, and that's all. Thank you. Thank you for the opportunity to present these aspects. And probably it looks quite different. A doctor, in this case a medical doctor, an anesthesiologist, trying to speak about such complicated stuff as algorithmic information dynamics. And not only this, but trying to use it. Thank you.